المحاضرة رح تتطرق إلى البوليمر إلكترولايت، أنواعه واستخداماته وأهميته. عنوان المحاضرة Polymer Electrolyte Classification. Polymer electrolyte is one of the main components sandwiched between anode and cathode to complete the circuitry in the battery. The polymer electrolyte have been attracted a scientific and technological importance because of their potential application in many areas such as lithium-ion battery, supercapacitor, electrochemical devices. The polymer electrolyte have four types of polymer electrolyte. Solid polymer electrolyte is the first type. Is defined as a solid solution of conducting ion. The ion can be transported inside and through the host under the effect of an electrical field. The fundamental of ionic conductance in the polymer electrolyte is the covalent bonding between the polymer backbone and the ionizing group. The advantage of use solid polymer electrolyte over liquid electrolyte in the battery system are A. Excellent traceability and flexibility that could enable the fabrication of ultra-thin lithium cell of various geometrical shapes so that high energy and power density could be achieved for versatile application. B. Higher safety due to the absence of flammable organic solvent. C. The high dimensional stability, which will lead to elimination of the separator so that further improvement in both energy density and manufacturing cost could be achieved. The second type is gel polymer electrolyte. The gel type membranes may benefit in the ionic transport mechanism, which is similar to that of their liquid component. Ionic conductivity of these membranes is closely related to the diffusion motion of low molecular weight solvent mixture within the gel. According to the formula, the ionic conductivity of liquid and gel polymer electrolyte sigma equal to NQ mu, where N is the charge carrier concentration, Q is the charge on the mobile species, and mu is the mobility of the ion. The ionic conductivity of gel polymer electrolyte depends upon two factors, which is carrier concentration and mobility. The conductivity of charge carrier N depends upon the concentration of the salt containing the mobile species. If this salt is completely dissociated, the formation of ion aggregation takes place, which shall lower the conductivity. Third type of composite polymer, solid polymer electrolyte, can be defined as the class of reinforced polymer with low quantity of micro or nanometric size filler particles to enhance film traceability as well as the strength. This electrolyte is obtained by doping ceramic particles such as Al2O3, SiO2, and TiO2, and carbon nanotube and others in the polymer matrix. The addition of filler particle to the polymer effectively control the growth of the passivation layer on the lithium electrode as well as increase its stability during long time storage. The use of ceramic filler tend to reduce the glass transition temperature and the crystallinity of the polymer, and therefore allow to amorphous polymer to maintain liquid-like characteristic and increase their conductivity. The increase in conductivity is mainly attributed to the decrease in the level of crystallinity in the polymer due to the presence of the filler. The mechanical strength and the electrochemical performance of the electrolyte are expected to increase with the decreasing of the filler size. Fourth type is polymer blend electrolyte. Blend is a mixture of two or more polymer. Mixing of two polymer is a well-established strategy for the purpose of obtaining material with combined superior property. These polymer blends have some unique properties that are different from the basic polymer. Polymer blend electrolytes are developed in such a way that they remain structurally stable during manufacturing, cell assembly, storage, and usage, as well as to prevent leakage from the container of the cell. Thanks for your attention.